Odd even jump. Understanding the question was much tricky than solving itself. So here we are given an integer array ARR and we have to return the number of good starting indices. So what is a good index? So we are at index I and from that index we will do few jumps, and if we reach the last index of the array then it will be called a good index. So we have to count the number of good index and return it. For doing the jumps there are few rules associated with it. So now let us see how jumps will be performed. We can jump from a index I to index j such that j will be always greater than I. That means if I am on index number 1, I can only jump to the right side of 1, that will be 2, 3, 4 and 5. Now coming to odd number jump, the condition here is specified like all the ARR of j that are greater than I and their values also are greater than ARR of I or equal to. From them I have to choose the smallest possible values. So let us take the example here. For index number 2, the value here is 13. So the value that are in the right side of 13 that are greater than 13 are 14 and 5, out of which 14 is the minimum one as it is stated here, smallest possible. So we can only jump from 13 to index number 4. So a valid odd jump will be from index 2 to index 4. Now let us see the second rule for even jump. Here it states that I can only consider the element which are less than or equal to the element at ARR of I, and from that I have to get the largest possible. To simplify it, if I am at index number 1, then I can only consider the element that are smaller than 10. So the element which are smaller than 10 are 8, 9 and 10, out of which I have to get the largest one. So the largest one will be 10. So for index 1 the value will be 10, and which are the potential candidate, that will be 8, 9 and 10, but out of these I want the largest possible, so that will be 10 as it is equal to ARR of I. So a valid even jump from index 1 will be to index 8. Now coming to the last type of jump, that will be no legal jump. So let us take the example here, index number 1, the value here is 10, and in case of even jump, if I look in the right side of the 10, I can't find any element that is less than or equal to 10. So we don't have a legal jump for 10, hence there won't be any jump. But in case of odd, you can see the value that are greater than 10 are 13, 14, I think all the values are greater than 10. So out of which the smallest one will be 12. So for odd jump, I can go from index 1 to index 3. Okay, so now let us understand the question. In the question, we have been given an array, and suppose the indexes are A, B, C, D, and E. Now we have to count the number of good indexes. So what will be the initialization here? Since we can say that when we are at E, we are already at the last index. So for each array, there will be at least one element or one index that will be good, that will be the last index. So our counter will be initialized to 1. Now what our question needs us to find, suppose we are at index A, so our jump will be like jump first jump, second jump, third jump, fourth jump, and so on. So from A, and let us take it, this blue I am marking for odd, and this green I am marking for even. The jump which is even or odd. So if we start from A, let's suppose we will be always doing our first jump, that will be odd. So from A, suppose our odd jump landed us to C. Then from C, I have to alternate, like my second jump will be even. So from C, I have to do a even jump. So if I did a even jump and I landed up here. Now again, it is my third jump, that will be odd. So I will follow the rule of odd jump and then I will try to go somewhere. Suppose the odd jump landed me here. So then I can say that A is a good index. So the list of good indexed can be A is there, we will find another, and say E will be always there by default. So A is there. Now I can say that again D, as we have seen, we have done an odd jump. So if we do a first jump from D, it will go to E. So D is also a good index. Now let us take example. Let's suppose from B I am doing my first jump, that is odd jump, and I jump to C. Now from C, if my odd even jump is coming to E, then we can say B can be included in this group. Suppose C also is included. So number of element I have to return and 4. Now let us understand this with the help of an actual example. ARR, which is equivalent to 10, then 13, then 12, 14 and 15. The index will be 0, 1, 2, 3 and 4. For our question, I will be taking two extra arrays, that will be Boolean arrays, that will be odd and even. What I will store here, that from a certain index, if I am able to like index number 0, 1, 2, 3 and 4, and similarly for this, let me write it, index 0, index 1, index 2, index 3 and index 4. Since for 4 we will be always at the last index, like it is the last index, so I will initialize it to true. Now what I will do, instead of moving from this direction, like from left to right, I will move from right to left. How it will be like this, why I am doing it, suppose I come by jumping from here, one odd jump I come to here. If I am able to find that whether by jumping from here even jump I am able to reach the end or not, then I can simply return true or false based on this answer. Okay, let us do a dry run, that will be more easy to understand. So since 15 is the last element, that's why we have done it as true, and the count, as I told, will always be initialized 1 because the last element is always at the last index, so we can count it as a good index. So here counter is initialized to 1. Then I am coming to index number 3. So from 3 my first jump will be odd, so I can go from this odd jump, like odd jump specifies what, that if I'm at element ARR of I can jump to the element that has greater value than this or equal to, and that should be minimum. So here we have 15 that is greater than 14 that satisfy a condition for odd jump. So I can say that yes, this is satisfied, and for this the odd jump is true. Now for 14, the even jump, we can see that to the right side of 14 there are no elements that are less than or equal to 14. So I cannot make a jump, so I am writing false. Again, we will, if we choose 2 as our starting index, so first we have to do a odd jump. For odd jump, let's say the values which are greater than 12. Okay, both the values are greater than 12, that is 14 and 15. So if we do a odd jump, we will land at index number 3. But from here we have to do a even jump. But I can see my even jump is landing here, like out of index. It is not possible. So even though from 2 I was able to do a odd jump to here, but the even jump is landing somewhere here out of bounds. So this won't be considered as a good index. So again we will say false. Now we will also check meanwhile that whether from here if we do even jump, whether we can go somewhere. So we can again see that 14 15 both are greater than 12. So our even jump will again land us somewhere here. So that is also not possible. So we will update it here as false. Now coming to index number 1. Now if I do my odd jump from here, so I can reach to index number 14. Like 14 and 15 are greater than 13, and it is the smallest one. So this will be my odd jump. But again, if I do even jump from here, it will go somewhere out. So instead of performing it every time, if I go from here 13 to 14, I can simply look whether the even jump here value is true or false. Since it is false, so by doing a odd jump here, we won't be able to get to the last element. So here also it will be false. Now we check whether if we do a even jump from 13, will it be any beneficial? Okay, for 13 we can do a even jump to 12. Okay, but from 12 can we do a odd jump? Yeah, we can do, but still by doing a odd jump we will land to 14. And we can see that from 14, that is index 3, the even jump is false. So again it will be false. Now we will again check for index number 10. Sorry, index number 0, value 10. Can I do a odd jump? Yes, I can do a odd jump, and I will reach to this index. But if I try to do a even jump, I won't be getting, and I will be getting out of array. Again, this won't be possible. By jumping I can reach to element number 15. So again we will write false for it. Now if I try that from index number 1, sorry, index number 0, I do a even jump. If I do a even jump, I can't do it because all the elements are greater than 10. So again it will be false. So if we see, there are two elements that can do a odd jump and reach the end. So our count will be incremented. We have to do it sequentially. I am just doing it in the end. Otherwise, first we are initializing this value as true. So our count will also be initialized at 1. Then we will move back and we'll check for odd jump. And if it is true, then we will increment it. Let us understand how we will calculate this, from which index to I have to jump to which index, that is how odd or even jump is calculated. So let us take an example. Elements are 10, 13, 12, 14, 11, 9 and 10. So indexes will be 0, 1, 2, 3, 4, 5 and 6. Suppose I am on index number 0 and from here I have to jump to even jump. How we will do? This is like a question of monotonic stack. So suppose we have a stack like this and we have a value, current value, that is 10. Current value is 10 and I am here at index number 1. So I will compare. For even jump, what is the condition? Condition is element should be less than or equal to our current element. So if for even jump, if we will look at this and we will find that 13, it is already greater than 10. We can't jump to here. Similarly 12, 14, 11, no. Then we will come at 9 and we will put it in the stack. Then I will come at 10. Since it satisfies the condition that 10 is greater than and equal to 10, we will come in the stack. Then we will look if the current element is greater than stack top, then we will pop the stack. So here we popped it and we pushed 10. Suppose we got 8 here. Then if we have moved here, then it is also a valid candidate, but in order to find whether it is the greatest of all the element, then we will again see it fulfills the condition that it is less than 10. Then we compare it with the stack top. Since we see that 8 is not greater than the top, then we will be moving forward. If it would have been greater than top, then we would have pushed it. Similarly, if we want to do it for odd, so again we are starting at index number 1 with value, current value equal to 10. For odd, what it specified, the value should be greater than or equal to min of all the values in the stack. So again we will have a stack. I came here, 13 is greater than 10, so we will put it in the stack. Then I went here, okay, 12 is also greater than 10, and then we try to put in the stack. We compare whether the stack top is less than my current element. No, 13 is greater than 12, so we will pop and we will push 12. Then we will move forward to 14. We see 14 is greater than 10, it satisfies the condition. For this min condition, we again come here, we check if stack top is greater than our current element. No, then we won't be pushing it. If it was, then we will move ahead. Now we came again, 11 is greater than 10, it is fulfilling the condition. Now for min condition, we are comparing with stack top. If 11 is stack top is greater than the current element, then we will pop the stack top and we will push the current element 11. Similarly, then we go for 9, but here we will compare whether 9 is greater than 10. No, we will move forward. 10 is greater than or equal to 10. This is correct. So we will come here, we will check whether stack top is greater than my current element. Yes, we will pop it and we will push 10 here. Then we will look at 8. If 8 is there, 8 is less than 10, so it won't be even considered. And suppose here if 10 was not there, till 9 was only there, then in our stack top the element would have been 11. So from index number 0 we would have jumped to index number 4. So first of all, I take the array size Then after that I will create two boolean arrays that will contain our even and odd value that will be of size n, and I will initialize them to false. Similarly for odd, size n and initialize to false. Then as we know, the last element will always be a good index, so we will initialize it to true. Now our count, since the last index will always be good index, so our count will equal to 1, and then we can iterate from here. So iterating from the second last index till I is equal to 0 and I minus minus. Now I will create two functions that will check whether after doing an odd jump I am getting or I am reaching the last index or not. So these are the things. So if I am reaching the last index, then I am assigning it the value true for further cases, and I will be incrementing the count. And if even check again, then e1 of I is equal to true, and we will return the count. Now coming to the helper functions. So my first function will be bool odd check. So we will be checking for I plus 1 direction. Like if we are at I index, we will be always jumping from I plus j to n minus 1. So that is the thing. Okay, first I have given odd, and then vector of bool, that will be even. Then in the end I will be giving our array. Now again I need size of the array. After that, what I need to do is, suppose I will get the index int idx with a function get smallest greatest, and here I will give an arr, suppose. Okay, so if my index is equal to -1, that it means that no legal jump. So if we don't have a legal jump, so we will directly return false. Else, if we are able to jump, then we will check we have done an odd jump. Then now if current even jump gives us the answer, like from performing a even jump from this index, will I be able to reach the last index? So if it is true, then what we will do, we will simply return true. Otherwise we will return false. So we have completed this function. Similarly, for even check, the function will remain similar. Yeah. Okay. 1 second. Let me copy and paste it. Yeah. And we will rename it to even check. And instead of getting the smallest greatest, we will get the largest smallest. And again, instead of once we have done the even jump, then we will check whether from current index the odd jump is landing us to last index or not. Now these helper function, now we have to implement this get smallest greatest function, and it is not necessary we use stack. We can directly do it with the help of a loop. Here I passed that, then n equal to the size of our array. Then after that, let's take a value for comparison that we take into max. Then index we are initializing to -1, so that in case of invalid jump we will get this. Then we are starting our jump from I plus 1, and it should be less than n and j plus plus. So what is our first criteria? If our current element is greater than or equal to the ARR of I, then if it is all less than the current value, like the current stack top, then we will do val equal to ARR of j and then idx equal to j and return idx. Okay, similarly we can write the function for get largest smallest. So instead of main, we will start from the minimum value. Again, index will be this, and if it is less than or equal to ARR of j, and if the value is greater than, then only we are doing it. Okay, I think we are good to go with our code. So now let us try to run it. 1 second. Run. Okay, we are getting correct result, but yeah, I have already submitted this result and we got time limit exceeded. So let us move to how to optimize it. Now let us see the optimization. Suppose for index 1 I want to find even jump, that is the value that is less than or equal to 10 in the right side. We don't have any value. For odd jump, if we look, the value that is greater than 10 to its right side, and it is the smallest value, that will be 12. So index number 3 with value 12. So if we now look, we have something called lower bound and upper bound. We can use it in any container that is in sorted order. It internally uses binary search. So if we read, lower bound returns a iterator pointing to first element which has value not less than val. So if we try to find the lower bound for 10, and if we have stored, since we are processing it from the back, if we have stored these elements, so it will be like 15, 14, 13, 12. Suppose there was some other element also 9. So it would have been like this. So if we now find the lower bound for 10 in this array, then we will get a pointer or iterator pointing to this value 12. So for odd, we can use the binary function, that is lower bound, to get the value that is greater than or equal to the value 10. Similarly, upper bound states that returns the iterator pointing to first element in the range which has value greater than val and if value is not present, then it will return the end iterator. So suppose for 10 only, there it will be returning 12. So we will, for this array, we will try to find the upper bound, then it will return 12. So if we decrement the pointer 1, so it will point to 9. That's how we can get the index of 9. Like we are getting the value 9. So to find the index, what we can do, we can create a map int comma int, and we will be storing like this. First the value, second will be the index. The key will be value, the key will be the value of ARR of I, and value will be the index. So using this lower bound and upper bound, our time complexity, suppose for 10 we are using it, finding it, we have to iterate whole array. So our time complexity for earlier approach would have been n square. But by using this iterator, since it uses binary search, it will be done in log n, and for each element we are doing it, so it will be n log n. So for this question, our time complexity will be O of n log n, and space complexity will be O of n, since we are using two array that store true and false value, that is order even of bool type. Now let us implement it in the code. Now let us implement that lower bound and upper bound logic. So first of all, I will take a map int comma int that will store value comma index. And why we are taking map? Because we want our keys to be in sorted manner. Next, let me comment this out. Now coming to odd check, let us auto it equal to mp dot lower bound and ARR of I. If it is not equal to, if it is equal to mp dot end, then that means no legal jump. Now coming for this auto it equal to mp dot upper bound ARR of I. So here we will check if it is equal to upper like a mp dot begin, then it will be a problem. So if it is not equal to mp dot begin, then we are doing it minus minus, else we will return false. And these things can be commented out. And if out of it second, okay, now we have to also input it. So mp of ARR of n minus 1 is equal to n minus 1. Similarly here ARR of I is equal to I. If we run, let's see. Okay, here we have to change it dot second, the index value. Okay, now it is Done. Let's try to submit it. Okay. Thank you.